In proposition 33, we're going to prove that if we begin with two straight lines which are equal and parallel, then if we join these 2 points to form two new lines, then these two new lines are also equal and parallel. Let's check out the text. The straight lines joining equal and parallel straight lines at the extremities, which are in the same directions, respectively, are themselves also equal and parallel. In the setup, let AB and CD be equal and parallel. And we're going to diagram that over here. So I've got my equal and parallel lines. Let's call this AB. And this is CD. And let the straight lines AC and BD join them at the extremities, as he says. So we simply join these two, AC and BD. And the claim is that AC and BD, there are two claims here, that they are equal and they are parallel. And how are we going to prove this? First he says, let BC be joined. So we'll do that. We'll join BC. Then, since AB is parallel to CD, that's a given, and BC has fallen upon them, the alternate angles ABC, which is this one over here, ABC, and BCD are equal to one another. And we just use proposition 29, by which we infer from the fact that two lines are parallel that alternate angles are equal. And hopefully it's clear that these two angles are alternate. And since AB is equal to CD, remember that's one of the givens, that AB is equal to CD. And BC, that's over here, that's going to be in common. So you can see where he's going with this. We have these two triangles over here. And BC is common. The two sides AB and BC are equal to the two sides DC and CB. So AB and BC are equal to the two sides DC and CB, respectively. And the angle ABC is equal to angle BCD, which we have in the diagram. Therefore, the base AC is equal to the base BD. And how is he inferring this? Well, if we go back one step, notice we have side, angle, side, side, angle, side. And so we just use proposition 4 to make this inference. And the triangle ABC, that's this triangle over here, is equal to the triangle DBC, or DCB. And the remaining angles will be equal to the remaining angles respectively, namely those which the equal sides subtend. And one more conclusion he draws from this. Therefore, the angle ACB, which is this one up here, is equal to the angle CBD. And that follows from the equality of these two triangles. Notice that both of those angles are opposite CD in this triangle and AB in the other triangle, which we've shown to be equal. Actually, it was given that they're equal. He continues, and since the straight line BC falling on the two straight lines AC and BD has made the alternate angles equal to one another, and what are those two alternate angles? That would be ACB and CBD. Those are alternate angles if we consider the line AC and BD being cut by BC. So we have the equality of alternate angles, and from the equality of alternate angles, we may infer from proposition 27 that AC is parallel to BD. And that was the other claim in this proposition, and he reiterates, and it was proved also equal to it. So in summary, we have AC being parallel to BD, and we've already proved that AC is equal to BD, and so we've taken care of this proposition.